Welcome back to Fun Facts Online. Today, we are journeying to the frozen twilight reaches of our solar system to discuss a discovery that has fundamentally changed how we view the ice giant Uranus. For decades, this planet has been a silent blue marble in our telescopes, guarding its secrets behind a thick veil of aquamarine haze and charcoal-colored rings. But in August 2025, that silence was broken. A new moon, designated S/2025 was discovered haunting the Uranian system, a tiny shattered fragment of a violent history that has finally stepped out of the shadows. This is not just a story about a rock in space. It is a detective story involving the most advanced telescope humanity has ever built, a missing piece of a 4-billion-year-old puzzle, and a chaotic environment where moons are ground into dust and reborn again. Let us begin with the discovery itself, because finding S/2025 was a triumph of technology over the tyranny of distance. For nearly 40 years, our understanding of the inner Uranian system was frozen in time, specifically in 1986. That was the year NASA's Voyager 2 spacecraft executed its daring flyby, whipping past the planet at over 60,000 kilometers per hour. In those frantic few hours, Voyager revealed a crowded, chaotic family of small inner moons huddled together near the planet's rings. Names like Puck, Belinda, Cordelia, and Ophelia. But Voyager's cameras were 1970s technology hurtling through intense radiation belts. They had limits. They missed things. Specifically, they missed S/2025 The revelation came on August 19, 2025, when a team of astronomers led by Dr. Mariame El-Mutamid of the Southwest Research Institute announced what many thought was impossible. Hidden in the glare of Uranus, nestled in the terrifyingly narrow gap between the moons Ophelia and Bianca, was a new object. It was small, barely 10 kilometers or 6 miles wide, and charcoal black, reflecting almost no light. It had not been found by a probe, but by the golden eye of humanity stationed 1,000,000 miles from Earth, the James Webb Space Telescope. Dr. El-Mutamid explained that the team was originally looking at the rings to understand dust distribution. However, when they processed the 40-minute exposure images from the near-infrared camera, there was a dot that did not match the background stars. It was a dot that was orbiting. This discovery was monumental, because it was the first time a moon had been discovered around Uranus by a space telescope since Voyager. It was a fossil, a survivor from a chaotic era. But to truly understand why S/2025 is so important, we have to look at the planet it orbits. Uranus is the solar system's most battered victim. Every other planet spins like a top on a table, upright, with a slight tilt. Uranus spins on its side, rolling around the sun like a ball. Its north pole points at the sun for 42 years, then plunges into darkness for the next 42. Its rings are vertical. Its moons orbit like the hands of a clock on a wall, rather than a plate on a table. This unique configuration is the smoking gun of a violent collisional past. Planetary scientists now believe that roughly 4 billion years ago, shortly after Uranus formed, it was stalked by a protoplanet roughly the size of Earth, or perhaps 2 times larger. In a cataclysm of unimaginable scale, this impactor slammed into the young ice giant. The energy released was sufficient to vaporize rock and ice instantly. The impact did not just tip the planet over. It likely pulverized the impactor and stripped away part of Uranus' outer envelope. The result was a superheated disk of vapor, dust, and molten rock that encircled the tipped planet. It was from this hellish disk of debris that the current Uranian moons formed. Unlike Jupiter's moons, which likely formed from a peaceful, distinct nebula, Uranus moons are children of violence, born from the wreckage of a planetary collision. S/2025 is a piece of that shrapnel. When the orbital parameters of this new moon were calculated, astronomers were baffled. The Moon orbits at a distance of approximately 56,250 kilometers from the planet's center. This places it deep within the danger zone of the Uranian system. It sits precariously between Ophelia, the shepherd moon of the Epsilon ring, and Bianca. This region is what dynamicists call packed. The inner moons of Uranus are crammed so tightly together that their gravitational fields are constantly jostling one another. It is a chaotic dance. If you were to nudge one moon just slightly, the entire system could destabilize, leading to collisions. In the 1990s, theorists predicted that the inner moons of Uranus are collisionally evolved. This means they are not permanent fixtures. Over millions of years, they crash into each other, shatter into rings, and then reaccrete into new moons. It is a cycle of death and rebirth. S/2025 U1 is likely a product of this exact cycle. Its small size of 10 kilometers suggests it might be a fragment from a previous collision between Ophelia and Bianca, or perhaps a rubble pile, a loose collection of boulders held together by weak gravity, masquerading as a solid moon. Its presence hints that the violent past is not just ancient history, it is ongoing. The Uranian inner system is a grinder, and S/2025 U1 is the grit currently passing through the mill. So how did Voyager 2 miss a 10-kilometer moon? The answer lies in the specific nature of the Uranian environment. The inner moons of Uranus are covered in a dark, carbon-rich material, likely radiation-processed organic compounds known as tholins. They are darker than fresh asphalt. S/2025 U1 has an albedo or reflectivity of roughly 0.04 to 0.07. It absorbs 93% of the sunlight that hits it. When Voyager flew by, it was moving incredibly fast and taking short exposures to avoid motion blur. A tiny black rock against the blackness of space, orbiting next to the bright glare of the planet, was simply invisible to the 1980s Vidicon cameras. It took the James Webb Space Telescope, observing in the infrared, to see it. In infrared light, the thermal glow of the moon and its contrast against the cold background made it pop out. The discovery required a technique called shift and stack, where multiple images are digitally shifted to track the expected motion of a moon, causing the static stars to streak while the moving moon becomes a solid point of light. The location of S/2025 U1 offers a tantalizing clue about the rings of Uranus as well. Uranus has a complex system of dark, narrow rings. For decades, scientists have suspected that there are shepherd moons keeping these rings in place, preventing them from spreading out and dissipating. Ophelia and Cordelia shepherd the bright Epsilon ring, but other rings seemed to lack guardians. S/2025 U1 orbits just outside the inner ring system. While it is too small to be a major shepherd, its gravity undoubtedly creates wakes or ripples in the dust. It may be responsible for maintaining the sharp edges of the fainter, dusty rings that Voyager saw but could not resolve. Furthermore, the moon itself might be a source of the rings. Micrometeoroids from deep space constantly bombard these small moons. Because S/2025 U1 has such low gravity, essentially allowing you to jump off it and escape into space, any dust kicked up by these impacts does not fall back down. Instead, it drifts off to join the rings. S/2025 U1 is essentially bleeding dust into the Uranian system, feeding the very shroud that hides it. Now, regarding the name. Following the delightful tradition started by John Herschel, moons of Uranus are not named after Greek or Roman gods, but after characters from the works of William Shakespeare and Alexander Pope. While the provisional designation is S/2025 U1, the astronomical community is already buzzing with potential names. The moon sits between Ophelia from Hamlet and Bianca from The Taming of the Shrew or Othello. Likely candidates will be minor servants or spirits, fitting for such a small world. Moth, a fairy from A Midsummer Night's Dream or Cobweb, are popular theories. given the Moon's tiny gossamer nature and its connection to the web of rings. The discovery of S/2025 U1 has reignited the call for a return to Uranus. The Uranus Orbiter and Probe, a mission prioritized by the Planetary Science Decadal Survey, is currently being planned for a launch in the early 2030s. This mission would not just fly by, it would park in orbit. It would be able to map S/2025 U1 in high resolution. We could see its surface. Is it a cratered monolith, a jagged shard, or a porous fluffball? Studying S/2025 U1 up close would act as a time machine. By sampling its surface composition, we could determine if it is made of the same material as the impactor that tipped Uranus over. It could be a piece of the alien world that died to make Uranus what it is today. In conclusion, the discovery of S/2025 U1 is a reminder that the solar system is not a finished painting. It is a movie that is still playing. Uranus, with its sideways spin and its shattered moon system, is a monument to cosmic violence. It teaches us that planets are not static. They can be knocked over, their moons can be pulverized, and from the dust, new worlds can emerge. S/2025 U1 is a tiny black dot in a vast, cold dark. But in that dot lies the story of a collision that shook a world to its core. It is a humble survivor, orbiting silently in the wreckage, waiting for us to come back and listen to its story. Thank you for listening to G Fun Facts Online.